Hey class, describe all solutions of AX equals B in the non-homogeneous system. And remember, homogeneous would be if vector B is all zeros, the zero vector. Non-homogeneous, you'll have something other than all zeros. Start with the augmented matrix, and we're going to put in matrix A followed by the last column being matrix B. Row reduce this on your graphing calculator. Again, unless you just want to go step by step and do it by hand, you can always row reduce these. Okay, so I wrote in the 3x4 matrix. After you do the row reduced echelon form on your graphing calculator, let's look at the pivots. X1 has a pivot, X2 has a pivot, but X3 is free. There's no designation for that third row pivot. Okay. So X3 is free, X2 is equal to 2, and that's highlighted down here. X3 is free, X2 is 2. If you were to move negative 4/3 X3 over, then X1 is equal to 4/3 X3 minus 1, that negative 1 in the last column. You could also write that as negative 1 plus 4/3 X3. Now let's put all this together in order. The solution vector X is made up of X1 through X3. X1 is negative 1 plus 4/3 X3. X2 was a fixed 2, and X3 is free. The only weight, I want to say, that is available is this X3. Notice we have constants of negative 1 and 2. We don't have one in the third row. And then X3 has coefficients of 4/3, nothing, and an unwritten 1. P is a vector, and it's all constant. V is 2, but it has X3 that's free out here. So your solution is both vectors, P plus the span of V3. Well, since that's a line, recall from the last video that if you only have one vector, and it was the answer to our homogeneous system back in that other slide. This one's non-homogeneous. So the way to think about this is you sketch this vector through the origin lightly, and you'll see in your e-text, if you were to read through your e-text, again, I highly encourage you to do that. It's a better backup to these lecture videos because they also have good diagrams and most likely clearer explanation too. But a non-homogeneous system will be a vertical translation of a homogeneous system's answers. For example, if we let these all be 0, we would get this as our solution. And we did that last video. Non-homogeneous, you will also have something to translate that vector to be your solution. Suppose the equation AX equals B is consistent for some B, and let P be a solution, which we had on the previous slide. Then the solution set of AX equals B is the set of all vectors of the form P, which is a fixed vector with no weight, plus that homogeneous solution, which was the vector that had the X3 in front of it. Okay, V sub H is any solution of the homogeneous equation where it's equal to 0 instead of equal to something not 0. Okay, so let's look at some extra examples. Note, this one's a homogeneous system. 3 rows, 3 entries to x. So we take each coefficient, write it as a column. The x2, that's the second column of coefficients. x3, that's 817. And then our last column is all zeros. When you row reduce, we have a free variable, x3. There's no pivot in the third column. Third row. x2 is equal to positive 3/4 x3. x1 is equal to negative 17/8 x3. Well, if we put all that in order, vector x, x3 was the only free variable, and so x we can write from the top to bottom as x1, x2, x3. x1 was negative 17/8 x3. x2 is 3/4 x3. And x3 was free, so we would just leave x3 alone. This system has a non-trivial solution because there is a free variable. Now, to look at the opposite of that, maybe there's a 1 here so that there's a pivot in every row. Then it only has the trivial solution. Because if there's a pivot here, x3 will be 0, and then you just end up with a whole slew of zeros for x1, x2, and x3. Trivial solutions if all these are 0. If you ever have a free variable, that won't occur because you'll have a free variable that can be factored out and used as a scale for the rest of the terms. Okay, let's look at one more. And again, these are just extra examples. We're still doing 3 equations, 3 unknowns. Translate out to an augmented matrix, homogeneous, because they're all set equal to 0. Row reduce echelon form that augmented matrix in your calculator. We get 1s on the main diagonal. Every row has a pivot. And so 0 vector is the only solution. This homogeneous system only has the trivial solution. Pivot in every row. No free variables. Describe all solutions of AX equals 0, where A is this 2 by 3 matrix. All right, now since it's supposed to be homogeneous, we set up an augmented matrix with matrix A and then a last column of zeros. Row reduced echelon form produces the second row is all zeros. Now that means we have a consistent system. We do have solutions, but we have infinitely many solutions. Okay, so our solution vector x is going to be non-trivial. x1, x2, x3. x2 and x3 are both free. Both free. x1, which has that pivot here, is positive 4. Remember, this is equal to 0, so that's positive 4x2 minus 3x3. 4x2 minus 3x3. Now, this solution vector has x2s and x3s. So x2, if you factor it out, you have a 4, a 1, and nothing. 4, 1, nothing. Then if you factor out an x3, then you have negative 3, nothing, and a 1. These, again, are free. The span of these two vectors, if you were to plot them, give them any kind of scalar multiplication and any direction, forward or backwards, positive or negative, that span will include your solution set. So if you had a 3-dimensional graph paper, or use computer software and you plot these two vectors, notice these are not multiples of one another, so they're going to go in two different directions and span out. It would almost be like, say you're working on a Word document and you do a click and drag. How, like, if you click here and then you drag, how it opens up a big rectangle to highlight your words. That's the span. But anyway, whatever these two vectors here span into, which would be a plane that goes through the origin, if you wrote that in parametric form, that's how you would write that. Some S and T, U and V are your vectors. The span of those two vectors contains your solution set to this homogeneous equation.